now that we have this gasoline, this is quote unquote raw gasoline, right? This is still doesn't have any processing done on it to make it usable in our cars, right? So what are the things that it goes through, whether that's processing or additional of ingredients to make it suitable for cars? Welcome to Behind the Shelf, a podcast about how everyday products are made. My name's Tarek.
And my name is Amar, and we are your hosts.
Today, we're going to be talking about gasoline, specifically
yeah.
this gas that you get from the gas station. Obviously, gasoline is a very massive topic. Everything we have has an element of gasoline in it and oil.
Yeah.
So we're going to be trying as much as we can to focus on gasoline and how it's made and what makes it. What are those numbers mean? 87, which by the way, I'm
the octane ratings. Yeah.
Just so you're prepared. I need to know what those numbers mean because I remember looking it up a while ago and I totally forgot what it means at this point. So I'm really eager to that part at least.
Yeah, I mean, I don't know about you, but gas is expensive here, man. And you're always wondering, like, what's in it that's making it so expensive? Like, is it supply chain? Is it the actual materials? Is it refinery? Is it expensive to dig? Like, and then why does Saudi Arabia have gas is cheaper than water? So who knows? I don't know. I don't know.
You reminded me, speak of expensive. During COVID here in the US, I remember filling 1 gallon. So typically here in where I live in the Chicago area, it's about $3.8 per gallon.
So for our non-US people, let's convert gallon because
3.9. Each 1 gallon is 3.9 liters. And I remember during the beginning of COVID, the price per gallon, I got it for like $1.99, I think. So like $2 for 4 liters almost of gasoline. I can't see this price now anymore. It's unfortunate.
Before we were all going to the office 5 days a week, right? And then COVID changed that, and now, well, that's why I got rid of my gasoline vehicle. I went EV.
Oh, you have EV
go to
now?
the gas station anymore. I didn't want to pay.
Look at you living the Western life.
I'm just cost savings life, man. I'm trying to go economical. I don't really care about going green. I just want to save money. But let's go back to what we're supposed to talk about. Gasoline. So, did you know the U.S. is the biggest consumer of gasoline in the world?
Yeah, I can see that because we don't have a great transit system here, especially across the nation. So you have to drive anywhere you go, and I'm sure the lobbyists in the automotive industry play a huge role in that, and making sure we don't have one. Yeah.
And okay, on the other side, United States is also the largest exporter of gasoline.
Oh, really? More than Saudi Arabia?
They're largest exporter.
Oh, wow, interesting. How many barrels per year, or what's the percentage of the total exports that comes from the
total
US?
Exports? I looked at so according to U.S. Energy, it's 16% global exports. 16% of the global exports.
16 comes from the US.
Comes from the US.
And so, what is the second and the third? Who's trailing after the United States in terms of gasoline production?
Yeah. So if we're talking specifically gasoline exporter, Netherlands is second, and then China is third.
I would not have guessed gasoline production is from the Netherlands, given how tiny the country is. Do they make that oil and convert it to gasoline, or
they may not necessarily? Yeah, they may not necessarily make or dig up the crude oil or pump it and all that, but they are the refiner, almost like the predominant refining country for Europe. And Europe is the region they refine for, and then they provide it. So on record, they are the exporter of gasoline on record.
Okay, so they just have a lot of refining capabilities that allows them to produce this much for all of the region. Okay, so when we talk about history then, how far back does gasoline date? I would imagine, so right now gasoline is only associated with the internal combustion engine. So did it exist before the ICE engine? What was it used for? Talk us through the history of when it was invented.
Yeah,
Or
so
created, actually, not invented. It was invented.
the first major milestone in kind of what we need to talk about is the first commercial oil well. And that in 1859 is the major milestone. Before that, the ancient civilizations were using bitumen, which is naturally occurring in tar pits and stuff. And they used to use it for, building materials. In ancient Egypt, they used to use it for mummification and stuff like that. But the actual gasoline was
Mm.
seen as a byproduct because people wanted kerosene, right? People wanted kerosene for lamps, for lighting, and gasoline was just the byproduct for them, and they didn't care about gasoline at that time. But what really triggered it is, you're right, the commercial combustion engine is what really drove the demand for gasoline. And that all happened in the 1960s and sorry, in 1860s and 1870s, as people all over the world were trying to get combustion engines and stuff like that. And two names that were very predominant in the space was Nicholas Otto and Gottlieb Daimler. So Daimler, Chrysler, Gottlieb, those
Daimler.
guys.
Okay. Yeah, yeah, yeah.
Yeah. So they were very predominant in the space. Exactly, exactly. And that's when, the kind of invention of the automobile, having a combustion engine that runs on a fuel. And when I say fuel, I mean gasoline. Ford came in the picture. And because of that, the demand for gasoline was going up. And so the production of gasoline also went up to meet that demand. And so let's talk about what gasoline means. Like, how do you get it? The oil from the ground is essentially
Hold on.
considered.
So essentially gasoline existed as a product but wasn't really used before the internal combustion engine.
Because they
So
wanted kerosene. They didn't care about gasoline.
so the only use for gasoline is in the internal combustion engine. There's no other use for it in our
They didn't
economy
use it, as
nowadays.
far as I was looking at, they didn't use gasoline. They were
And
using
even to this
kerosene.
day, it's only used in engines.
Yeah, what do you use gasoline for? Natural gas
Yeah.
is in your barbecue, but
Okay.
not gasoline.
So yeah, so I'm vaguely familiar with how like gasoline is obviously produced out of crude oil, and I remember reading a little bit about it a long time ago. It's like the whole process of refining oil that gets into gasoline. So when we talk about refining, is it the same site where that produces all the byproducts that we're familiar with for from crude oil, or are they like specialized? And then how does gasoline specifically get produced in the process?
Yeah, so usually what happens is the crude oil goes to a refinery. The refinery is almost like a one-stop shop for the most case, because the process they do essentially creates all these products. So
Hmm.
it does it based on boiling points of the crude oil. So when you put crude oil in, it goes into distillation. We'll talk about it a bit more when we talk about the manufacturing process, but just for a milestone highlight, is they heat the crude oil, and essentially as the products are boiled off, that's when you get these products. So you would get
Hmm.
petroleum gas first, you would get these chemicals called naphtha, then you would get your gasoline, so that's for cars, then you get jet fuel, kerosene, then diesel fuels, then you get heavier hydrocarbons, lubricating oils, then all the way at the bottom, the heaviest is like bitumen, tar, stuff like that. And so that's how they kind of did that. And before the advent of the combustion engine, where they needed gasoline, they were looking for kerosene for lamps and lighting and stuff like that.
It seems like our use of oil obviously what was a lot more limited than it is right now. And right now we're just making the most out of it, right? It seems like we're not really.
Yeah.
Is there any waste that comes out of processing crude oil, or is it all 100% used?
No, I mean, not 100% used. There is some residue. They're like really heavy hydrocarbons. So if the heaviest of them all is not used in the tar and all the byproducts, essentially you have this sludge, unusable sludge. And then that's the waste we're talking about.
Okay, okay. And you kind of touched on it. So how are these products and how is gasoline specifically made into the format that we're familiar with at the gas station?
Yeah, so let's go through a little bit of milestones until we get today. In 1890, you heard of this guy, Carl Benz.
Yeah.
So Carl Benz is
Hmm.
he's known as the father of automobiles because of him, he did the first commercialized motor vehicle with combustion engines, and he used gasoline as fuel. And so, like I said, the demand increased like crazy. As we approached the 1920s, they started adding tetraethyl lead to the gasoline. Now, you may have heard of leaded gasoline. This is
Yeah.
what they did.
What was the reason? What was the
Yeah,
value
so
for
so
adding it?
they yeah, so they added because they wanted to improve performance. They wanted to improve and reduce pre-ignition. So when I say pre-ignition, I mean at a specific rate in the combustion chemical reaction, you don't want the fuel you're adding to combust earlier than it needs to be. And so that
Efficiency. Mm.
pre-ignition was reduced because of adding this compound. And at this specific time, during this time period of 1920s, they also started using catalytic cracking. So catalytic cracking essentially is they add a catalyst to the heavy hydrocarbons that we were talking about, right? Those big sludgy ones, the heavy hydrocarbons. And they would add these. At this period of time, they used like acidic, natural occurring clay as a catalyst. And the heavy hydrocarbons were broken down, and you would have a higher yield of gasoline. So they were able to break up the higher hydrocarbons to get the lower to mid-tier hydrocarbons. So essentially, they were able to improve the yield of gasoline. And by this time, gas stations were everywhere. 1920s, 1930s, gas stations were everywhere.
So there's chemicals, that kind of trying to kind of digest what you took us through. So outside of adding the lead that helps control the ignition point of the gasoline itself, those other chemicals that you mentioned that they add to the heavy hydrocarbons, is that specifically for gasoline, or is that something that was used in the other byproducts of crude oil?
They've used it for anything they want. Essentially, the heavy hydrocarbons, they would use the same method, and they could get kerosene, they could get natural petroleum, they could get gasoline. It would just improve the overall yield of what they're looking for. So in
Okay,
our case,
mm,
they would use this catalytic cracking to get more gasoline.
okay, so it's essentially a bunch of chemicals that would help convert the crude oil into the other byproducts that we're currently familiar with. So it increased the yield essentially out of the
Correct.
crude
Correct.
oil. So
Correct.
for gasoline specifically, at that time they added lead. Was that the only ingredient that they added to the gasoline to help control the ignition? Was there anything else that they added to it for the old ICE engines?
No, at that time, that was the major thing they added and blended it together with the gasoline.
Okay. And the one other stuff that has been added since then, because I know it's unleaded, right? So, and I don't think
Yes.
leaded exists. So how do they
Yeah.
substitute that with like in the modern gasoline? How does it substitute the use of the lead?
Fair question. So as we approached the 1970s, there was a big push. You're right. For unleaded environmental concerns, public health policies, they took away leaded gasoline. And as we approach the 21st century, so nowadays, there's a big push for environmental concerns, promote renewable energy. And so that's why you might have seen your gasoline with like subtitles almost like biofuels and ethanol is added. So our current gasoline now has biofuels and ethanol added to kind of reduce carbon emissions, promote environmental awareness and stuff like that. So our gasoline has biofuels and ethanol.
Why do they add them? And then same with the ethanol. What do
Yeah,
they add it
that's a
now
fair
to
question.
the gasoline?
Yeah, so when I say biofuels, it's almost like corn oil, for example, is one of the biofuels that's added,
Hmm.
and ethanol is added. Essentially, it reduces the carbon emissions. Ethanol specifically is almost like an oxygenate. It increases the oxygen content in your fuel and improves the combustion. So also because they improve combustion, you have less carbon emissions, less gases in the air, stuff like that.
So ethanol essentially is helping it oxidize more so that the emissions of the gasoline is less of a CO and it's more of a CO2, which is something that obviously trees can break down and convert into oxygen.
Yeah,
Is that
you're right.
essentially what ethanol is doing?
Yeah, that's what ethanol is doing. Yes,
Because, yeah, CO is like carbon monoxide, which is
not
a
good.
byproduct that trees cannot break down and convert into oxygen. It's actually deadly for trees as well and the environment. But CO2 is actually the food, obviously, for trees. So ethanol helps convert that CO into
Photosynthesis.
CO2. I
Yes.
see, I see. Okay.
Yes.
And then okay. So are there any other additions? Is there anything that they add besides the ethanol and the oil to help it get to where it is now?
Yeah, they do. There's a whole blend of stuff they add now. And I want to cover that in when we talk about the manufacturing process so it makes a bit more sense. First things first, survey, you find where you need to drill, they drill. It could take a few weeks, it could take a few months. They find where the oil well is and then they have to pump it out. They pump it out. You know those like you've seen the cliche, any movie, any
That
show. It's that
crank that goes up and down.
yeah, the little cranky arm thing, and that's
Every video
essentially
game I played had those.
it's essentially pumping the oil out. Once you get the oil out, you gotta transport it to a refinery. So what they do is they put it in the tanks, or now a lot of places have these direct pipelines straight from oil fields straight to a refinery, and they have pipelines. For example, in North America, there's a really popular pipeline that's coming out of the West Coast straight into the U.S.
That's the pipeline that goes from Alberta, Canada, all the way down to like Texas and the Midwest, right? And I remember there
Yeah,
was a lot of dispute about having
it's
it
called the
run
Keystone
through
Pipeline.
the Keystone. Okay, there you go, the Keystone Pipeline. So there was a lot of dispute around it going through Native American preservations, and it was like, do we build it? Do we not? And yeah, so Keystone.
Yeah. There's a whole slew of issues we don't want to get into, but essentially, one example is the Keystone pipeline.
Hmm.
And refining usually takes between 1 to 3 days. The first thing right off the cuff is the oil is added into a giant furnace, 350 to 400 degrees Celsius, and it takes a few hours. And the compounds are separated based on their boiling point. So as I mentioned, or crude oil has a specific chemical compound, and as it's being heated, different chemical compounds are almost boiled off as it goes through the stage. And the heavier compound hydrocarbons, so for example, tar is very, very heavy, and that's the last thing to boil off. And so that's how they separate, for example, kerosene compared to jet fuel compared to gasoline. So all these products are coming off as they're being boiled off.
So I can control what I'm producing based on the boiling point, based on the temperature at which I'm quote unquote cooking the crude oil, right?
Correct. So as it's boiled off, these things are separated and go into a separate tank. And if you ever seen any image of a refinery, you'll see these giant silos, huge farms,
Yeah.
piping everywhere, and
Yeah.
that's because of all these things that are happening simultaneously.
So you're taking from a major furnace. So essentially, every refinery has at least one furnace that, out of which has pipes that takes all those byproducts into their respective silos.
Yeah, and we'll flash up a image or almost like a diagram to better understand. But yeah, you're right. This is exactly what it is. You'll have several main furnace silos that have piping outside at different levels, and that's because of all these separations that are going on.
And what is the temperature for gasoline?
Gasoline is about 120 degrees Celsius.
So if I boil crude oil at that temperature, the vapor that comes out is gasoline that I then capture.
You will so at that point you would have already got petroleum gas, which is almost like your barbecue gas. You would have
Hmm.
already got, naphtha chemicals. You would have, and then you get your petroleum for gasoline, or your petrol for gas,
So it's more of a step phase approach to get to
where
gasoline.
you need to. Correct.
You got to capture
Correct.
everything else. Okay. So when you take out this gasoline and that goes into a silo, at this point, it's actually hot and it's vapor. So how do they convert it into that liquid form that we're familiar with? And then what are the process steps to convert it to where we see it right now? Because I would imagine this is obviously unprocessed. Maybe they need to clean it. Maybe they still need to add the additives, the ethanol, and the other stuff we talked about, right?
So first, before we get to what happens to gasoline after it's condensed and then it gets into the tank, there's a few things that also happen to increase the yield of gasoline at a refinery. Catalytic cracking, something I mentioned before. What they'll do is they take the heavy hydrocarbons and they break it down into smaller hydrocarbons. For example, gasoline, and they use a catalyst like zeolites, which is essentially a compound that has a framework of silica, aluminum, and oxygen. And at high temperatures, high pressures, the heavy hydrocarbons are broken down. Another step that's also occurring is reforming. So low octane hydrocarbons, using platinum as a catalyst, those low octane hydrocarbons are rearranged in high temperatures 800 to 900 degrees Celsius to get higher octane hydrocarbons. So, for example, low octane gasoline becomes high octane gasoline.
So this is essentially your first step, and that's the easiest way to extract gasoline out of crude oil is boiling. And then
Yep.
you can increase your efficiency by introducing chemicals essentially and you mentioned catalysts and other chemicals as well to help break that crude oil further and get more gasoline out of it.
Yes. Yeah.
Okay.
Yeah. This is exactly it. So the heavy hydrocarbons from the crude oil, you are now doing all these things to get more gasoline, higher yield
Got it.
gasoline,
Just improve
better
the output.
Yeah. Exactly.
So now that we have this gasoline, this is quote unquote raw gasoline, right? This is still doesn't have any processing done on it to make it usable in our cars, right? So what are the things that it goes through, whether that's processing or additional of ingredients to make it suitable for cars?
Yeah. So as I mentioned before, our current gasoline is a well blended multi-compound, I guess. So let me break it down on this list. So in a blending unit, so now your raw gasoline is flown into almost like a blending unit, as other stuff is also being added simultaneously. Everything is automated. Refineries are notoriously automated. Okay, so what happens is naphtha gasoline is low octane. That's the base unit. Then they also add reforming catalysts. So I talked about reforming like platinum, right? Platinum is added. FCC gasoline, moderate octane, which is almost like a blending component. Then you have something called the acrylate, which is a high octane. That's for stability of your compound. Isomerate, so this is the light naphtha, high octane molecules. Butane, so lighter fluid, butane is added small amounts just for vapor pressure. Then oxygenates, so I mentioned this, like ethanol is added, increases the oxygen content of your fuel. It essentially improves combustion. Improving combustion, less carbon monoxide, less environmental effects. Then additives like antioxidants, so prevents oxidation of your actual fuel. So your fuel has a better shelf life almost.
It's a preservative. It's a preservative essentially, right? It's like food.
Yes, like food. Except don't eat your gasoline.
That's oddly similar. Okay.
Yeah, and then corrosion inhibitors. These are specific compounds that are added. Essentially, whatever fuel system it goes into, it prevents corrosion.
So it doesn't make the gasoline eat away into the piping,
your
and
engine,
all the pumps.
Your pipes.
Okay.
Exactly.
Okay.
And yeah, all this is blended. Now blending. So I had to look this up because in my head, I'm thinking, in our food we have this high shear mixing, all this fun stuff happening. Yeah. Not the case. So this is very specific. Flow determines mixing. So essentially, all these things I mentioned are in separate tanks, and it using specific flow rates, they're added into the blending tank, and that flow in creates the mix. So there's no agitation. There's none of that. The actual flow into it creates the mix they want.
So it's like a continuous process almost. It seems like you have various streams.
Process.
Okay. So they have various streams of oils or chemicals that are just blending with each other. And a lot of those are obviously liquid, and there's any mechanical agitation that takes place, is what you're saying?
There's no mechanical agitation because you don't want this thing heating. You don't want this thing igniting.
Friction,
you don't want any static. Yeah, you don't want any of that. So the actual flow is what's creating the mix.
The mix. Okay. So it feels weird to ask, are there quality checks that happen in this stage? Like how are they making sure, because especially if you're not doing any mechanical mixing, how do you make sure that you're quote unquote in spec every time across the board?
Yeah, man, there's a huge list of quality checks these guys do, man.
Maybe we'll focus on how do you make sure that the blend is what you're looking for gasoline.
So let me take through what almost they do on a regular basis, not like quarterly, not yearly, but what they do every time. So everyone's heard of the word octane. I repeated the word several times here. Octane. So octane rating is very important. Every batch is tested. What they do is they take a compression engine and they put their sample in the compression engine. Essentially, it takes the ratios of the sample, and then compares it to a standard reference ratio. So they know all the blends are there in a proper ratio.
So, and then you've been saying octane. What's the high octane, low octane? What's the purpose of that specifically in gasoline, and why do certain cars require high octane versus others?
Yeah, so octane is essentially just the value assigned to gasoline based on its ability to resist knocking. Now again,
Mm-hmm.
knocking is another jargon. Knocking essentially is resistance to premature ignition. So you want the fuel you're adding into your engine to combust and ignite at a specific rate. Some
Yep.
fuel is lower in quality, so it ignites before the rate that it needs to run at. And the better fuel ignites at a specific rate, slower burning rate. And so all that essentially is resistant to knocking. And premature ignition, you don't want premature ignition to occur because it creates incomplete or inefficient combustion
Inefficient,
rates.
exactly. Yeah.
Yeah, and it causes overheating on your fuel system engine or whatever. And over time, it also causes mechanical damage. So
Because
yeah,
you're essentially looking for your gasoline in the internal combustion engine. If I'm thinking through each of the cylinder, you have this piston that's compressing the gas before it ignites it with those spark plugs. You're essentially looking for it to ignite at a specific pressure. Otherwise, you're not going to get the optimal efficiency in your engine.
that's exactly right. That's
So
exactly right.
that octane number, is that what the 8793 number
Yeah,
is that what that is? So the higher the
that's
number,
exactly
the
what that is.
higher.
So
Yeah. Yeah.
yeah, you're right. That's exactly what it. Regular gas is 87, mid-tier gas is 90, the premium is almost what is it, 91, 94. And so some engines require premium gas because that's how it functions. Our poor people like me do 87 gas, and
You just said you
that's
have an EV, so I don't know how poor you are, but we can continue.
economical decision.
Yes,
But yeah,
yes.
so that's the number, right? That's the number. It's octane refers to the ability resisting premature ignition. Higher the number, better the gas, better the fuel.
So the higher the number, the higher the resistance to premature ignition, the
Correct.
higher the efficiency. Does it refer to anything like 87? Is that a specific factor or a metric that it's referencing?
So essentially, the numbers mean it's almost like a blend ratio. So essentially, 87 means it's 87% one hydrocarbon, and then the other percent of the other hydrocarbon. 90 exam is again the blend of 90% versus the other thing 91, 94, etc. So essentially, it's a
So it's a
blend of
blend ratio,
two
essentially. It's
hydrocarbons.
just a blend ratio.
Yeah,
Okay,
correct,
okay.
correct. There's a lot of other very important things they do. One is vapor pressure. This is measured because vapor pressure determines emissions. There's a specific analyzer unit they use. Fuel is placed in a sealed container and then heated. And whatever vapor it kind of creates, that vapor is essentially measured. There's a specific regulation, specific spec around this.
And that helps with that's probably compliance with the EPA and environmental agencies. Okay.
Yeah, yeah. And then next is evaporation. So gas evaporates at a specific rate. So there's a specific curve on heat and evaporation. And what they'll do is they'll take their gas sample and they measure it that, hey, it evaporates at this temperature at this rate. And essentially, this check ensures controlled, consistent combustion rate, that the fuel is not combusting at random, points, that they can say, okay, my fuel is going to always combust in this range. And so that's what they're checking. The next thing they check is sulfur. Again, you don't want any sulfur. Sulfur is not good. They measure sulfur content in the sample. What they'll do is they'll use an X-ray unit, throw X-rays onto the fuel compound, and they will measure their energy emitted. So if there's sulfur in it, they'll know how much energy is emitted back. And that's how they measure sulfur content. They also look at benzene and aromatics. Essentially, it reduces smog, and there's certain public health regulations on how much benzene and how much aromatics are in your gas. If you like that sweet smell in gasoline,
Oh, I love it.
that's benzene. That's benzene.
Okay, so what
To
I'm
be
smelling is benzene. Okay.
to be honest, I really like the smell of gas. I don't know
I
about
think
you.
a lot of people like it, I think. I don't know why.
So
And
that's what it is, right? This is what's causing that sweet smell is the benzene, the aromatics, and what they'll do is they use gas chromatography to know how much of these things are in it. I
wait,
don't
so
know
is that a
if
specific ingredient that they add to make it smell like that? To make it like
no
give it a more of a unique smell to it?
the benzene is just one of the almost like
Ingredients.
yeah, it's not exactly added separately. It's the natural occurring compound within those blending units that we talked about.
Okay, okay, yeah. So that and then you mentioned aromatics, like that kind of threw me off. I got me to think, do we have something that they add to make it smell the way it does, or this is that natural smell that
If you
gasoline has?
recall, I don't know if you recall organic chemistry, benzene is circle and the benzene, essentially benzene is aromatic.
Okay, so it's the core ingredient, but also is what gives it the smell. Okay.
Yeah. Okay. So gas chromatography is how they measure this. And they also do the same thing. You use gas chromatography for oxygen. If you recall, oxygenates like ethanol are added, right? And essentially, we discussed this quickly, and you mentioned this: it reduced carbon monoxide emissions.
Mm-hmm.
And so they want to know how much ethanol, because there's again regulations around how much of these things can be in your gasoline. And the last two things are color appearance, so visual inspection. The one thing that is not automated is visual inspection. So specific technicians are there. They're looking at, hey, is my fuel sample free of debris? Is there any impurities in it visually? And they have a color chart. So they compare the fuel color or the gasoline color with what it's supposed to be. They have a color chart. They compare and they're like, all right, cool. This color matches what it's supposed to be. And there's no impurities. Check. And then the last thing is density of your oils, of your gasoline sample. They use a density meter, regular density meter, and measure the fuel sample density in specification. Check. And those 8 things are the major things they look at in their quality checks for gas.
That is a very detailed. I don't think I've ever seen a process that has this many quality checks that they look for, and it sounds very comprehensive. You're looking at the composition of your gasoline, you're looking at the color, the impurity, you're looking at the combustion level, you're looking at every specific detail of how this gasoline looks, performs, and it even is transported so that you make sure that it's specification. So you're essentially making sure you don't screw up the ICE engine. It sounds
Yes,
like it's very, very sensitive. That's why you're doing all those
it
checks.
is.
And some of them even
There's
sound,
so much stuff.
yeah, some of those tests sound a little bit redundant of each other, but probably they detect something slightly different and make them do it. Okay,
Yeah.
so you've gone through your quality checks. That gets into a truck, or does that get transported into a pipe? How does that get made into the gas station with the truck eventually?
Yeah, so the most common method is pipelines because pipelines offer a transport over a long distance at a cheaper rate, and it goes into your distribution terminal, which essentially packages it up on where it needs to go. Whether it needs to go on a truck for short distances, or it needs to go on shipment tanker over international waters, for example. There's a lot of different things, and barrel. I know. We keep saying barrels of units, barrels of oil, barrel. Essentially, that's just a measurement unit. It's not where oil is packaged.
So there are no barrels. You just kind of
There are
crossed
no,
my
there are no barrels, but they
crossed my
are
image of
pipelines.
how we package and store it, which also makes sense because a barrel is like it's a barrel,
Yeah,
and
that's right.
that makes it into our gas station.
Yeah, that's it.
That's it. Well, Omar, thank you very much. Appreciate taking us through this very crude and very labor. It
I like
sounds
what
like
you said. Nice.
very chemistry heavy, I would say,
It is.
journey.
It is. Yeah.
And thank you all for listening to Behind the Shelf. We hope you enjoyed this episode with us. Please like and subscribe. Let us know what you think about this episode. If there's something that
Yep.
you want us to cover, also hit us up and we're happy to cover it in one of our episodes. With that, my name is Tarek.
And my name is Amar. Have a great day.